I'm going to show you how to graph linear equations. We're going to start out graphing linear equations that are in slope-intercept form. We know that they're in slope-intercept form if, one, they're solved for y, and they're simplified. And so they look like y equals mx plus b, where m is the slope and b is the y-intercept. Okay, so if we look at number 1, you'll notice here we have an equation of a line. It's solved for y. It has a slope and it has a y-intercept. Okay, when you graph an equation in slope-intercept form, you start step 1 by plotting the y-intercept. Okay, so in this case, our y-intercept is our b. That's the cheese. He stands alone, meaning he's not next to the variable. He's not next to the independent variable. Okay, he's all by himself. So I'm going to go on to the y-axis, which is the one that goes up and down like a yo-yo. Yo-yos begin with y. Okay, I'm going to plot him at y equals 5. Step 2, that's your action. Now we have to take action. And we use our slope, also known as that familiar phrase, rise over run. You'll know forever and ever. Okay? And it's good to write the slope right next to it. If your slope is negative, like it is in this case, put that negative sign in the numerator. Oops. Let's erase that m. It should be a negative 2/5. Sorry about that. Okay? So the reason why I put the negative in the numerator is because that's our rise, and it's easy to know that positive you rise up, negative you rise down. Typically students kind of mix up left and right more than they will mix up and down, so this helps eliminate a little mistake. So this tells us that we are going to rise -2, which means we'll go down 2, and then we're going to run in the positive direction. So this, if we put our negative in the numerator, our denominator, our down, will always be to the right. So we know we'll go down 2 and to the right 5. So, and that's exactly what I'm going to do. I'm going to go down 2, and I'm going to run to the right 1, 2, 3, 4, 5, which will end up being right there. And now since I have 2 points, and technically I really just need 2 points, I can now connect the dots and draw my line. So again, step 3, then connect the points. So let's review the steps. Step 1 is plot the y-intercept. Step 2, do your action, your rise over run. And step 3, connect the points. Okay. We look at number 2. Okay. Here number 2 is in slope-intercept form. Okay. Well, we know that it's in slope-intercept form because it's solved for y and it's simplified. But you might be wondering, where is the y-intercept? Well, there isn't anything there. So that is just like adding 0. So you guessed it, our y-intercept in this case is 0. So I'm going to start by plotting 0. My y-intercept is at 0. Now I still have my rise over my run, which in this case again is -2/3. So I'm going to go down 2 and to the right 3. So I go down 2, always starting at your y-intercept, and to the right 3. 1, 2, 3. So that means I'll end up right there. Now, there's room on this graph, so if you wanted a 3rd point, you could go ahead and keep going. Continue the pattern. Down 2, to the right 3. Nothing wrong with adding another point. In fact, if you wanted to get a point in the other direction, well, you can see, if you follow the pattern, instead of going down 2, you go up 2. You would go up 2, but then you would have to go to the left 3 to make sure that you're still in line with the other points. And there you can see I have a nice set of 4 points all on a line, and now I can connect the dots. Okay. Well, there's other equations of a line. Okay. Number 3 is an equation of a line. Only notice this one looks really funny. But what's really cool about it, and I'll show you 4 at the same time, what's really cool about these is these are super easy. See, if you look here where it says x equals 4, all you have to do is go on the x-axis, okay, and find 4, plot the point. In fact, on this line, it doesn't matter what y is, x will always be 4. So you just draw a line right through there, and it turns out it's this vertical line that goes up and down. Likewise, in number 4, you'll see that it's missing some information there. That's okay. Just like in number 3, only this says y equals 1. So all you have to do is go on the y-axis, where y is 1, and just like before, you're going to draw a line through it, only this line is going to go horizontally. And that's the trick to those. Those are super easy. Let's try another one. Y equals x minus 4. This is number 6 on your little packet. So here, again, we have it in slope-intercept form. Okay, it's solved for y and it's simplified. Okay, and you'll notice that the y-intercept, the cheese that stands alone, is at -4 in this case. So we go to where y is -4 and we draw a little point. Okay, then you might be wondering, well, I don't see anything next to the x. Does that mean it's 0? Oh no, if it was 0, you would have 0 times x, and you get 0 minus 4, which is -4. In this case, there's that invisible 1 that's next to there. So the slope here is actually 1 over 1, which means you rise up 1, you run over 1. They're both positive. And that's all you need to do when you do this. You're just going to rise up 1, over 1, up 1, over 1, up 1, over 1. So he's actually pretty easy. But sometimes students get confused because they don't see that number and they think incorrectly that the slope is 0, but that is not the case. I have another type of equation that you'll be asked to graph. And these equations are in what we call standard form, where x and y are on the same side. Okay, we've actually practiced a lot of these, and we've practiced solving for y so many times. So if you can solve for y, then hey, you can get your equation in slope-intercept form and solve it just like we did before. And that is exactly what we will do here. So if we take our equation, 5x minus 4y equals 12. We want it in slope-intercept form, which means we want to solve for y. So we box the term we're solving for, making sure you include that minus sign. Don't forget this minus sign that's in front of there. He belongs to that -4. Wherever that 4 goes, that minus sign better go with it. Okay, so draw your street. Who didn't make it inside the box? This guy right here. Kick him to the curb. Get him to the other side of the street. So we do that by subtracting 5x because he's positive. Now, whatever we do to one side, we have to do to the other. He's not friends with the 12, so we're not going to line him up. Okay? So we don't want to accidentally try and subtract them. 5x minus 5x is 0. We're left with that minus 4y. So please don't forget that. We're left with that minus 4y equals 12 minus 5x. Now, notice we don't have y all by itself yet. We've got this pesky -4 there. And that means that I am multiplying. Whenever we have a number next to a variable, you're multiplying. Okay? So I'm actually multiplying -4 times y. Well, what undoes multiplying by -4? You guessed it, dividing by -4. But you've got to make sure you divide everything by -4. Well, -4 divided by -4, we want a +1, and that gives us a +1. Good thing. We're left with a y equals, what's 12 divided by -4? Positive divided by negative is a negative. 12 divided by 4 is 3. Now here, notice, we have a negative divided by a negative, so that's plus. And then go ahead and leave him as a fraction, because we'll use our rise over run, and writing it as a fraction is a lot easier than trying to decimalize it and plotting it that way. Okay, well now we have it in slope-intercept form. Okay, so we're going to start with a y-intercept at -3. So I'm going to plot my -3. Remember, that's your subject. Okay, well now we have to go to our rise over a run. Our rise over run, that's our action. And I'm going to write rise over run. We have another example. Okay, our slope in this case is +5 over +4. So that means I get to run up 5, 1, 2, 3, 4, 5, but then I get to run to the right, 1, 2, 3, 4. Okay, so my next point is right here. Whoops, let's try and get him on that little coordinate point, sorry. So, just to make sure we've got this correct, okay, I went 1, 2, 3, 4, 5 up, so +5. And then I'm going to run to the right, 1, 2, 3, 4. So now I can connect my points. There we go. So that's all you have to do. So when your equation is in standard form, where the x and y are on the same side, we just added one extra step, and that is solving for y first. Then you take your subject, plot the y-intercept, use your rise over run, connect the dots. Okay. Let's go ahead and write those steps down. Okay. So when the equation is in ax plus by equals c form, 1. Solve for y to put it in y equals mx plus b form. 2. Plot your y-intercept, which is b. Right? 3. Use your rise over run to get second point. And then finally, connect the dots. Good luck!